m2 into z2k plus m3 into z3k by m1 plus m2 plus m3. So if you equate the coefficient of I, j and k, you will get x is nothing but equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Y is nothing but m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3, and z is nothing but m1 z1 plus m2 z2 plus m3 z3 by m1 plus m2 plus m3. So we can write x is equal to sigma mi xi by sigma mi, y is equal to sigma mi yi by sigma mi, and z is equal to sigma mi zi by sigma mi. So if we have the coordinates of different particles of a system of particles, that is, if we have x1 y1 z1, x2 y2 z2, and x3 y3 z3, so we can get the coordinate of the center of mass. Its coordinate will be x, y, z, where x is equal to sigma mi xi by sigma mi, y is equal to sigma mi yi by sigma mi, and z is equal to sigma mi yi zi by sigma mi. So given the coordinates of different particles in a system of particles, we can find the coordinate of its center of mass. Now if there is a single line of symmetry in an object, the center of mass of the object will lie on this line of symmetry. And if there exists two or more than two lines of symmetry in an object, then all these lines of symmetry will pass through a common point, and the center of mass of the object will lie on this common point. Now let's see what is the center of mass of a continuous mass distribution. So earlier we have taken the example of a system of particles where we have three particles and we found out its center of mass. Now let's say that we have a continuous mass distribution, that is, we have an object A of mass m, and we want to find out its center of mass with respect to a point P. Say this is point P. Now to find it, what we'll do is we'll take a very small mass dm inside this object, and let the position vector of dm with respect to point P is r, and let the position vector of center of mass, that is point C, is rc with respect to point P. So rc will be equal to integration of r dm by integration of dm, or r dm by m. So this is how we find out the position vector of center of mass for a continuous mass distribution. Now let's take a solved example. So here we need to find out the center of mass of the shaded region. So here the mass of each square is 1 unit, and the length of the side of each square is also 1 unit. So what we'll do is we'll divide the shaded region in 5 parts. We take these 4 squares of mass 4 unit separately, and this 1 square of mass 1 unit separately. Similarly, we have these 2 squares of mass 2 unit, this square of mass 1 unit, and these 3 squares of mass 3 unit. Now to find out the center of mass of the entire shaded region, what we'll do is we'll find out the center of mass of each of these 5 separate regions, that is the region with mass 4 unit, the region with mass 1 unit, the region with mass 2 unit, the region with mass 1 unit, and then the region with mass 3 unit. So recall that if there exists 2 or more than 2 lines of symmetry in an object, all of them must pass through a common point, and the center of mass of the object lies on the common point. So if you see the bottommost region, that is this region, here also we have 2 lines of symmetry. One is along x-axis, that is these 4 squares taken together are symmetrical along this line, and also along y-axis, that is these 4 squares taken together will be symmetrical along this line and this horizontal line. So the center of mass of these 4 square will lie here at the intersection of the lines of symmetry, and the coordinate of this point is 2 and 1 by 2. It is clear from the figure, since this is 1, this is 2, this is 3, this is 4, this is 1, this is 2, this is 3, this is 4, and this is 5. So the coordinate of center of mass is, x coordinate is 2 and the y coordinate is 1 by 2. Similarly, the center of mass of this region, that is the region with 1 square, will be the intersection of these 2 lines. So the x coordinate of center of mass will be 1 by 2, and the y coordinate would be 3 by 2. Similarly, here the x coordinate of center of mass would be 1, and the y coordinate would be 5 by 2. Here the x coordinate of center of mass would be 1 by 2, and the y coordinate would be 7 by 2. Similarly, here the x coordinate of center of mass will be 3 by 2, and the y coordinate would be 9 by 2. This is 9 by 2. So we have the coordinates of center of mass of these 5 regions. So now we can calculate the center of mass of the entire shaded region. So as we have already defined, the x coordinate would be sigma mi xi by sigma mi, that is 4 into xi is 2, plus 1 into xi, here xi is 1 by 2, plus 2 into 1, plus 1 into 1 by 2, plus 3 into 3 by 2, by sigma mi, that is 4 plus 1 plus 2 plus 1 plus 3. So we have 8 plus 1 by 2 plus 2 plus 1 by 2 plus 9 by 2 by, this sum is 4 plus 1 plus 2 plus 1 plus 3 is 11. So we have 10 plus 1 plus 9 by 2 by 11, or 11 plus 9 by 2 by 11, or this is equal to 31 by 22. So the x coordinate of the center of mass of this shaded region is 31 by 22. Similarly, we can find out the y coordinate. The y coordinate would be sigma mi yi by sigma mi. So this is 9 by 2. So this will be equal to 4 into 1 by 2 plus 1 into 3 by 2, that is 3 by 2, plus 2 into 5 by 2, that is 5, plus 1 into 7 by 2, that is 7 by 2, plus 3 into 9 by 2, that is 27 by 2, by sigma mi, which is 11. So here we get 2 plus 3 by 2 plus 5 plus 7 by 2 plus 27 by 2 by 11, or this is equal to 7 plus 5 plus 27 by 2 by 11, or 12 plus 27 by 2 by 11, or 51 by 11. 51 by 22, sorry. So now we have the x coordinate and y coordinate of the center of mass, that is